So clean coding is, why do we write code? It'd be nice if people could answer this question. Why do we write code? To get paid. What exactly is coding?
What are we doing?
To solve problems, to solve a repetitive problem, to express ideas. I like that answer. To get output. Okay. We could reinterpret that as to get a result. Shubham said to solve a repetitive problem. That's interesting. Stress on repetition, because we want to say that we want to solve a problem, but we don't want to be the ones doing it. The computer is the one who's doing it. That's why repetitive. So repetitive is boring for humans, but it's easy for computers to do that. Convert data to information through some algo. You went into some really deep things there. The best answer here that I would say is abhirups, to express ideas. I say we code as a way to communicate. We use languages to communicate, right? Programming languages are also used to communicate. We communicate instructions from human to computer. And most of us, we get stuck at this point, human to computer bus, and we don't think about it anymore. But if I say coding is just expressing yourself to a computer in a language that the computer understands, I would be wrong. That is right, but it's not the entire answer. Computer understanding you is only one part of coding. Coding is a social activity. I've said this many times before. It's not just conversing with the computer. It is communicating with everyone else who understands code. So not only do you have to get the computer to understand you, you need to have other programmers, other developers on your team understand you as well. And that's why it's very important to write clean code, readable code, understandable code. Our goal is not to have the computer understand us. Computer will understand anything, even assembly language. But why don't we code in lower level languages? Why don't we use assembly language or Fortran? That's because it's important for the humans to understand it. It's actually more important for the humans to understand it, because we're the ones writing it, we're the ones maintaining it, we're the ones using it. That's why we have higher level languages like Python and C++ today. And what's the power of Python? The power of Python is readability. The fact that it's written like it's English, and almost anyone can understand it, even if you don't really code. So that's why readable code is so important. You're writing a code only once, but that same code is going to be read by many people over a very long period of time. And it's very important for you to, make sure that that code can be understood by people. Now, yeah, I have made a document
Which has some words in it.
So these are some terms that we'd like to keep in mind today while we're talking about readability in code. Can everyone see my screen? Just give me a confirmation in the chat. Okay, sure. So I have made 3 words in bold, and the reason is these 3 words are the main terms today. All of these terms are all very overlapping. A lot of these terms can be handled by something else in the list, but these 3 are the main 3 points: refactoring, reusability, and readability. So let's go through the list one by one. Let's remove this from here for now, and let's keep this at the top. Functional decomposition. So when I asked you what is code, why do we code? Alina said we code to solve problems. So we can think of an algorithm as a series of instructions, a recipe of sorts. And a lot of these instructions are not very straightforward. They're not very simple. Some of these instructions could be complex. So if I have a recipe and I'd say I cook pasta, and the first step is to boil pasta. Second step is to make the sauce. Now, making the sauce is not one instruction, right? It's consisted of several small instructions. I have to cut the vegetables. I have to something, mix something, blend something. Those are many instructions that can be represented as one instruction, make the sauce. Boiling the pasta, I have to pour the water, I have to turn on the gas, I need to pour the pasta into the pan. Again, it's one instruction, but it's not a simple instruction. It is composed of several lower level instructions. And if I say an algorithm is like a series of instructions, like a recipe, then even your code follows this. It's not just a simple instruction. An instruction into several smaller instructions. And that's what you should be doing. So functional decomposition is breaking down your code into smaller steps. Suppose I want to write a code which draws a box. And I want to break it down into functions. So what are my instructions? I'll be pen down. So I put the pen down on the paper. I go forward, and then I turn left. And then I go forward again and turn left and go left and go forward. Then pen up. So maybe I could have a function for turning left. Maybe I could have a function for going forward. And maybe this entire thing could be a function called draw square. This entire thing is one function. And suppose I want to draw a lot of squares. So maybe draw grid. And this calls draw square. So that's an example of functional decomposition. This makes the program more higher level. You don't have to really worry about the implementation of certain things. You can think of it like a black box. Like you want to draw many squares, but you don't know how to draw a square. That's okay. That's a different problem. Drawing a grid means drawing many squares. It's okay if I don't know how to draw many squares, but like how to draw one square, as long as I can draw many squares. And then I'm doing draw a square. That's when I'm concerned with drawing one square and not with anything else. So one function in programming terms, a function is thought of to be a verb. And this is a very common concept, actually. If we see a program as a language, the functions are the verbs. They do something. They alter the state of something. So one function does only one task and no more than that. And you have to make sure of this. Like very often we do this in our code. We have a function that's doing a bunch of things. Do that. One function, one verb, one task. So functional decomposition and small functions. These two go hand in hand. Always break down your code into smaller functions and keep the function small. Gorilla sandwich is a term that my mentor came up with. And there's a story that a man was traveling via ship, and he was traveling with a gorilla, but live animals are not allowed on the ship, but food is allowed on the ship. So he just kept a piece of bread on two sides of the gorilla and said, "This is a gorilla sandwich. It's food, it's allowed." It's a terrible joke, but it's an analogy for the functions. Avoid gorilla sandwiches. Keep the function small. You don't have to fit everything into one function and say, oh, it's doing one thing. Maximum, especially in a language like Python, maximum keep a function 10 lines, no more than that. Next thing, fail fast. I have a function which returns the factorial of a number. It takes an argument, integer argument, and it returns the factorial of that number. Now, if I enter a negative number in the parameters, if I give -1, we know that negative numbers don't have a factorial. But that's not something the function is concerned about, right? It's not something the program is worried about. Program takes an input, it is an output. So here, failing fast means handling trivial cases early. So when you're in a function, you can just say def factorial. You have your number, which is integer. And if n is less than 1, return 0. 0 is an invalid output because factorial cannot be less than 1. So when you have a 0, you know that you've got a negative number, or 0, less than 0. When you return 0, you know you've got a negative number. Not only that, but you are not bothered with the rest of the function anymore. You don't care what happens in the function. It's a wrong input. You should not be getting the correct output. So you return. You return immediately, because if you stay in the function for too long with the wrong input, there's a chance that you might end up with an output which is a logical error. Like, it may not be a runtime error, it won't be a syntax error, but it'll be a logical error. If that happens, logical errors are very difficult to debug. Not only that, but also it complicates things. If you know that this is wrong, there's no way forward, then don't go forward. Come back. Don't pursue that function anymore. It's not only about saving time, but it's mostly about saving the logic of understanding what's actually happening. And even as humans, we do this very often. If we see that something is wrong, we immediately leave it. We don't go forward with it anymore. So readable code is basically code that follows human intention, human logic. If a human would not go forward with this logic, then why would a computer do that? The next one is if else. I've written this. It doesn't make sense on its own, but this list is actually a list of words that will help me remember what I have to talk about. So when I'm talking about if else, I'm talking about a certain programming practice that is very common among people who are not used to writing readable code. That is if condition, then return true, else return false. How many of you have written code like this? Have any of you written code like this? You can tap. Sejal says yes. Very honest, thank you. No one else? Yes or a no? No also works. Sometimes. Pragya says she used to. Okay, so instead of that, what do you write now? Return condition, yes. So if you have a Boolean evaluates to a true or a false. Now, if true, return true, else return false, is very lengthy and a very big pet peeve for most people. That what if we just do return condition? Then we're just returning whatever we need to return. We don't actually have to do that entire, it's wasting a lot of lines of code. You're expanding a very simple thing into 4 lines when there's really no need. It's not really doing anything. So that not really doing anything, that redundancy, is avoiding donkey variables. It's not the same point. This is a different point. But this is on a related note. So for example, n equal to input. And now I do int n equal to int of n. And now if I do x equal to n by 2, how many variables am I using? There's 3 different variables, n, int n, and x. Instead, I could just truncate this whole thing to int the input by 2, and I'm done with 1 variable. So what exactly is a donkey variable? A donkey variable is not really a standard term, but again, it's something my mentor refers to a lot. A variable that does nothing but carry information from one point till the other. There is no other purpose of the variable other than carrying information from one variable to another. So just eliminate that entirely. There's no need to keep that in your code. It doesn't really serve any purpose. Unless, of course, it improves the readability. Now, this is some decision that you have to make by yourself, whether the existence of a variable improves the readability of your code or not. That is your discretion. But in most cases, in a lot of cases, it might not. So avoid donkey variables. Now, looping etiquette is something very common in Python. This is very Python specific. That is, Python has something called a for each loop. The for loop in Python is a for each loop. And in C or C++ or Java, we're used to writing for int I equal to 0, I less than something, I++. Now, a lot of people started writing code in C or Java, and they're used to writing loops like this. So when they start learning Python, they just translate this code to Python. And when they do that, they do for I in range of some number. This is not Pythonic code, because this is, especially, this can be Pythonic code, like this is still excused, but if we do something like print array of I, this is not Pythonic code. Because you are, Python does not support this kind of a loop. Python supports a for each loop. So for each loop means for each item in container. And range is basically a container. It contains items from 0 to j-1, integers. Now for each integer in this range, we print array of that index. Instead of that, what we do in Python is for element in array, whatever you have to do. Now, I said print here, but again, a better way of printing might be print unpacked array. This is also more Pythonic. The biggest mistake people make when they're writing code in Python is they just translate code from the language they know to Python. And that is, it's like having It's like having a knife and using it to open a packet of chips. Okay, there's a lot you can do with the knife, but opening a packet of chips is not really the best way to use it. So there's a lot you can do with Python, but translating C code to Python, you're not really doing much. You'd just rather write C. On the other hand, if there is some loop where you need the index of the array, like element, then the etiquette for that is for I element in enumerate array, and then continue with whatever you have to do. So here you get the element as well as the index. If there's anyone who does not really understand what enumerate is doing, please write in the question and answer Q&A section. I'll go into details if you need it. Yeah. Then one of the biggest parts of programming is naming. Naming is one of the most important parts of writing code. Yeah, thumbs up there if you have a doubt about enumerate. So naming is very important because if you come back to a code after maybe 2 weeks and you end up seeing code which says x equal to n square, y equal to n by 2, a equal to x minus y, these convey no information. X, Y, A, these are, well, unless you're using mathematical formulae, these don't really make sense. If I just write G equal to F into H plus L, they don't really make sense. They don't convey much information. But you want code that's conveying information. That is readable code. Code that you can understand is when you know what it's doing. And for that, naming is really important. So when you're naming functions, don't call it fn and it's doing something. Call it what it's doing. I said function is a verb. So make the name of the function the verb. Name the function whatever it is performing, whatever the function is doing. So if it is doing something like finding an element, then I could say index my typing, yeah. Index of array and search element, so key. Okay, so it gets the index of the key in the array. Or if I'm doing something like sorting, so I just say sort array. Name the function exactly what it's doing. And in case your function returns a Boolean, then the name of the function should be a state, like a yes or no question, true or false question. So def is prime. So this is a function which tells you if n is prime or not, yes or no, true or false. So that's how you name functions. Naming variables is also very important. If you're naming an array, you can call it array. You don't call it something like x or a. A could be array, but it's a little ambiguous. It's fine if your names are long. Typing a few more letters, it's not a big deal. But if you can't understand your code, then that's a big deal. So a little extra typing goes a long way. A little bit of extra effort and your code is much better than before. So also in Python, naming follows a special convention, which is snake case. So if you're naming functions or variables, you use lowercase letters, separated by underscores. So is prime or count numbers. It's separated by underscore, all in lowercase. That is the Python snake case. When we are writing code, the lines of code should not exceed 80 characters. And in case it does, it might. Suppose you're writing a line which calls a function which has a really long list of parameters, arguments, and that's fine. So you have arg1, arg2, and going on. So instead of that, you write function, enter, arg1, arg2, and you keep going. And then you close the parentheses like this. So this is also a convention. It's called hanging arguments. I think that's what it's called. And again, there's some specific rules about, like, not rules, conventions about how to write it, where should the parentheses be, and if you can have an argument in the first line or not. You can't. I mean, that's a convention, you shouldn't, but it's not really that strictly followed. So it's just nitpicking. Indentation, yes, like I said about hanging arguments, indentation is important. You can't have them like over here. This is not correct. You have to have a layer of indentation. And indentation is very important in Python, because if your indentation is wrong, your code is wrong. Spacing as well. In Python, there's a funny rule that you can't mix up tabs and spaces in your code. So there's a debate over which is better, tabs or spaces. And the Python style guidelines say spaces. So avoid using tabs in your code. Use spaces, and always use 4 spaces. Some people use 2 spaces, and that's not a good idea. The style guidelines, they don't allow that. So now let's get to these 3 main points, that is refactoring, reusability, and readability. So refactoring is a little difficult to explain. So let's start with reusability. Code has to be reusable. So let me give you an example, that I want a function that returns me 3 to the power of 2. So I create a function and I say return 3 to the power of 2, and I return that. But maybe the next day I woke up and I thought, okay, I want 5 to the power of 2. So I can't use this function anymore. This function is useless now. So now I thought, okay, let me do something a little more intelligent. I'll have a parameter, and I return the square of that, and I call this square. Okay, so maybe the next day I decide that I want 5 to the power of 5, or maybe 5 to the power of 7. And now this function won't work because it only returns the square. So now let's have a function named power, which returns n to the power of p. So now this function is a lot more reusable than whatever functions I had written earlier. And not just that, let me give you another example of reusability. I have a requirement in my code. I need to write a function. Let's say a function which returns the square. So I don't know if you've heard of lambda functions or not, but let's have squares, and it uses list comprehension. I hope the people here know a little bit of Python. Let's say, okay, let's not use Actually, no. Okay, let's have okay. Let's have an array. Okay, suppose there's an array. It exists, and I want to have n square for n in array. So this is something that in Python called list comprehension. It's a very simple way of writing a list, making a list. And this is the Pythonic way of how usually we navigate lists. So what this is doing is, suppose I have 1, 2, 3. Squares becomes 1, 4, 9. This is what I'm getting. Now, suppose I have another place in the code which uses this n square. Somewhere else in the code, I need to have, something else. Somewhere else in the code, suppose I need to use n square. So a equal to n square, b equal to x square, c equal to d square. I'm using this in a lot of places. So having this over here is not helping me. I need to reuse this piece of code. So I create a function, f square, and it just returns n square. So now I can actually use, over here, it's just square, and that's a small piece of operation, is just n square, but it's not necessary that the operation has to be n square. It could be a much larger operation. It could be something really, really large, maybe n into cos 50 degrees plus, pi into sine. I'm having fun with this. Sine 30 degrees, maybe something as ridiculous as this. And it's used several times in my code. So instead of writing the same thing over and over again, I can just create a function and call that function every time I need this piece of information in my code. That's also reusability, and that's not the only place. So I use this rule when I'm writing code. It's not that straightforward. Writing reusable code, it's not always very easy. Even very experienced programmers, often we end up writing solutions where, we could have done better. So I follow this one rule when I'm writing code, is no repetition. Your code should not repeat, no redundancy. Anytime you see you're writing the same line of code again, check yourself. See if you can, reduce that to one piece of code and then keep using that code. Readability, I have talked about for a long bit of time now. So readability, avoiding donkey variables, naming is very important. Naming very important for readability. Looping etiquette, also very good readability practice in Python specifically. Small lines, indentation, even especially in Python, a lot of people do this. There's a joke that semicolons are not allowed in Python, but that's not true. Semicolons are used in Python, but in a different way. So I say a equal to 5, semicolon b equal to 10. So this is 3 lines of code written in one line. And if you use a semicolon, that indicates the end of a line.
People in the Python community hate using
semicolons. Even if it's 3 very short lines, please don't use this. Please keep it as 3 different lines. Or you can use tuple unpacking, which is a comma b comma c equal to 5 comma 10 comma 15. This is also Pythonic. This is also fine. But using semicolons to combine different lines into one line, that is not a very good idea. So small lines, small functions, fail fast, return early, these allow readable code. Now, refactoring is the most powerful tool that you can have when you're writing clean code. So I'll just show you an example of where I've used refactored code. Yeah, so this was my initial code, and let's not look at that. Okay, this is a refactored piece of code, and the part here that is refactored is the fact that month and time zone, they're all taken as data. I forgot to mention, when you're writing a constant in Python, the constants have to be in capital letters, all caps. So that's the difference between a variable and a constant. Variable is in small letters, constants are in capital letters. Also, very important, do not use global variables. So anything that you're defining in a global scope, it has to be a constant. It cannot be a variable, because global variables are very unreliable. And if you're changing them, then it's very easy to lose track of them and end up with a lot of errors. So global variables you must avoid. If you have to use something like a global variable, use a class variable. So make a class, use class variables, but don't use global variables. And refactored code, it follows this principle. Code is data. Data is code. So you have to use data in a way that it makes your program easier. Refactored code is scalable code, reusable code. Suppose I have these time zones: Los Angeles, New York, Buenos Aires, London, New Delhi, Beijing. And this is just a small list. This is one list. But if I have more places that I want to add, instead of making any changes in my code, I just have to add them to my time zone dictionary. That's the only change I need to make. If my code had not been refactored, then I would have to make the changes within my code, and that's not a good idea. I have another piece of code. Okay, let me just find the code. So is there anyone who doesn't really understand what refactored code means? I know I haven't gone into it much, but there's a question. Oh, that's Opirup. Okay, it's in this tab. Yeah. So this is a function, a code that's printing a pattern. And you'll see it has constants defined over here, like width, underscore. This is a line feed, and it's denoted by /n, which is a new line. This is backspace, space. Now, the funny part is, if I want to make any changes to this pattern, all I have to do is make the changes in the constants. So instead of underscore, if I give a star, 7 lines, then you see the pattern changed. But I didn't have to make any changes in my code. All I had to change was the constants. RP stands for repeating pattern, starting pattern, ending pattern. So yeah, that is what refactored code looks like. It's scalable, which means if you need to change, make any changes in the inputs, or maybe make the scope larger. Maybe right now you're taking 3 numbers as an input, but maybe later you have to take 20 numbers as an input. Can your code handle that? Is your code reusable? Is it doing things in a smart way? Is it using data at the beginning? Pre-processing is a very important part. Have you used pre-processed data? And pre-processing is when you have your input data, but you're not really using that because it's in a form that is not very usable. So you pre-process that data, you convert it to a form that is usable, and you use that in your code. So pre-processing is also a really powerful tool when you're coding. So that is covering the terms. And now we're going to do something a little interesting. And we are going to do some. So I'll share my notebook. Actually, I'll share the entire screen. Yep. Can you see my notebook? Check. Yep. Okay. So I've taken competitive coding is very famous or infamous for having some not very good coding practices. So I've been hunting code forces, and I checked the submissions, and I've come up with some codes, 5 codes that people have written for actual problems, actual submissions in a contest. And we're going to try and convert these to more readable code and see if we can submit those, because I want to show that code can be readable without compromising on the time complexity. Writing readable code doesn't mean that you suddenly can't do competitive coding anymore, because it is very much possible for you to write code which is readable and also optimized. So let's get started. So the first question is, it's very long, but you don't really have to see that. Just see these 2 points. You have a string, it contains A, B, and C. In one move, you can erase an A and a B. In another move, you can erase a B and a C, anywhere in the string. And now you have to see if you can erase the entire string or not. Okay, so this is the submission that I have taken. I would like if people pointed out places where we can improve. Like maybe so wait, I should share the tab actually. Yeah. So in the first question, can you tell me some place where maybe you could tell me the line number. This is line 1, 2, 3, 4. 4-line code, very short. Is it visible or do I have to zoom in? I think zooming in would be nice. Okay, now it's very zoomed in. Virup says line 4. What do you think line 4 is doing? Line 4 is actually very interesting. Someone from IIEST was the first person to introduce me to line 4, like that type of coding. Yeah, it's printing a yes or a no. And it's doing that in a really funny way. So it's using string slicing, which means if A is not equal to 0, then A not equal to 0, which means if A is not 0, then this is true. Which means this becomes 1. So it's basically slicing 1 to with steps of 2. So N and O, that gives me a no. Now if A is equal to 0, that means this becomes false. So that's 0 sliced with steps of 2. So that's Y, E, and S. That's a yes. So instead of this, I'd like to change this line. And I'd say, yes, if Actually, I don't want to make changes here. Yeah. So print yes if A is equal to 0, else no. Do you think that's more readable? Like, what are your thoughts? What's your opinion? Do you think this makes the code better? Or do you think you could do it in a different way? What would you do? By a large margin. Yeah, I think it's a better way to do that. Now, as for the logic, this is not really a very good problem to write readable code on because I think this is implementation based. Oh, it's math based. And math based competitive coding problems, usually they follow a particular logic, and it's that logic is not very readable or very obvious. So the code is not obvious as a result. So last one was cool. Yeah. So here's the thing, this kind of coding is called clever code. So yes, it does look cool, I will not lie. Clever code is very clever, but it's too clever. It's too clever for other people. The objective of writing code is not to show off, it's to make yourself be understood, have other people really understand what you're writing and what's going on. So if you're working in your team, if you're working with a bunch of people, you can't write clever code because the team might not appreciate that. It's not cooperative. So I don't think there's any other changes we can make. There's some changes with the spacing, for example, putting spaces around operators is a good idea. So if there's some space, it automatically makes it a little more readable because you're giving yourself, a little more space. Everything is not crunched up together. And apart from that, there isn't much that I would change. So let's move on to the next problem. In this problem, you have an array of numbers, okay? And first input is your number of test cases. Second input is the length of the array. And third input is the array itself. So you have an array of numbers, and all of these numbers are the same number except for one. So for example, I have an array that is 10, 10, 10, 13, 10. So I need to return the index of the odd one out. So this would be 4, 1 indexed, because 1, 2, 3, 4. Length of this is 5, so 1, 2, 3, 4 is 13. So I return 4. Actually, I forgot to do one thing. Okay, let's do that at the end. Let's do this first. So okay, let me just copy paste this. Yeah. First thing, what lines do you think are weird? Would you change? Not very readable? You don't really understand the logic? Which lines would you like to modify? 4. Yeah. What is 4 doing? 4 is finding the minimum out of S where the key is s.count. So the minimum is found on the basis of the frequency of the numbers in the array. And you are finding the number with the minimum frequency. And then you're finding the index of that number and then offsetting it by 1 because it's 1 indexed. That took a little bit of explaining. How would you change this? So we know that the frequency has to be 1 if you're looking for the odd one out. I told you about pre-processing, right? If there's no way for you to work with the current data that you have, the current input, then change the input, pre-process the data, convert it into a form that you can use. So what if I convert it into a dictionary? We are not really doing competitive coding. We are writing clean coding. So it's fine if we use a little bit more of memory. So for element in, first of all, S is not a nice name. Let's call this array or element in array. We have to create a dictionary. Actually, we're not even concerned with different elements. Like there's going to be repetition, but we're not concerned with the repetition. So what if I do set of array? Then we get unique elements in the array. That cool? Let's get a dictionary where the key is the frequency. So array.count element. And the value is element. So now we have s.index of frequency 1. S is array right now. Does this make more sense? It might not make more sense from a readability point of view, but it does make more sense from the logic point of view. Like the number of lines is not reduced or anything. But when you're pre-processing the data, you're actually converting it into a form that is easier to use. And when you're doing that, you're actually simplifying the problem. You're breaking it down. You're taking it one step in the right direction. You're breaking it down into two different problems. Like, okay, let me convert this into something usable, and then let me work with that. So that shows a kind of thought process. At least this is probably how I would write this code. And also another thing I would do is this input hanging for no reason. I would assign it to something. Just for the sake of not having it just being there. It's not doing anything, it's just there. So let me just assign it to something, even if I don't use that variable. Would you do it in some other way? Like anyone? If I not equal to I plus 1 or I minus 1, then print I. Okay, so suppose you're, okay, let's have some examples. 10, 11, 11, 11. So in this case, 10 is not equal to 11, but that's just one data point. So how would you say that 10 is the element that we're looking for? Oh, you're saying, okay, so 10 is not equal to 11. Okay, let me change that then. So 11, 10. Now the first element
Not equal to 10. So then your program would say
11 is the odd one out when it's actually 10. So it has to be and then. So I not equal to I plus 1 and I not equal to I minus 1. Cool. So let's try that out. For dash, why am I typing this again? All right, so we're not using the extra space. For element, okay. So we need the I as well for I comma element in enumerate array. Like we said, we use enumerate for cases like this. If, no brackets, sorry. If element not equal to array of I minus 1 and element not equal to array of I plus 1. Here we'll have a problem when the element is the last. Okay. Do you see the problem here? No. So what we have to do is, okay, let's use the length. I plus 1 mod length. We break out of it, right? So break. And in the end, we print I plus 1. Did that work? Let's try. Stick to test cases. Yeah. Have to convert this to integer for x in. So I actually prefer using list comprehension. Some people use map for that. Okay, where am I? Oh, sorry. Okay, this gives, let's check. Oh, cool, that works, I think. So this seems to work. Does it look better than this code? I know this code has just 4 lines, but what are the lines that are different? We're just using a for loop. We're using a condition, and if that condition is satisfied, then we break. Can we make this more readable somehow? Don't use list comprehension. For this, what should I use instead? Right, we don't really need that. Let's see. Yeah, that works. That's right. So I think we've brought this down to a pretty neat solution. I actually think this probably performs better than the original solution as well. So cool stuff. All right, let's move on to the next one. So this one is a weird question that's a little difficult to explain. So we're just going to work with the code. We're just going to change the code, modify this, and okay, so where do you see this going wrong? Like one very obvious thing that, yes, semicolon alert. This has a lot of semicolons for absolutely no reason. So let's get rid of those first. Oh my God. Like, you see, even the if condition, there's no space, no indentation, no line break. It's just directly going on to the statement. So, like, could you have guessed that that was the body of the if statement if before I made the break in the line? Because it took me a very long time to guess that. You know, when it was like this, I thought this was some kind of dictionary or slicing or something. But then I saw, oh, it's the body of the list. Body of the if statement. Similarly, over here, body of the while, semicolons everywhere. Okay, so now this is in a more presentable state. All right, improvements. Which lines? How would you improve this? So one thing I would do is, I'm not very fond of this kind of a line, a equal to question mark multiplied by n. So instead, I would say a dot count of question mark equal to n. So that tells me if the entire string is made of question marks or not. What is this line doing? It's replacing the first occurrence of the question mark with an R. So I already know that the string is made of, like, entirely made of question marks. So instead, I could just say R plus A of, because replace with one, oh, A of 0, or no, you're thinking in terms of C++ actually. Strings are immutable in Python. Yes. That was cute. Okay. So strings are immutable in Python. Otherwise, we could have just done A of 0 equal to R. And that's why I'm using slicing. I'm using the entire string from the first character onwards, and I'm changing the 0th character and replacing it with an R. Another thing I realized, A is a terrible name. I said that when I was saying replacing question mark in A. What is A? Let's just call it S for string at least, because A really makes no sense. Now, I actually like this logic. It's not a bad logic. Just replacing all possible occurrences with, whatever they have to replace. I don't know the question. I haven't really read it, but let's keep this logic. And this is a lot of typing the same thing, but it's a function, so it's not like we can reduce that. It's already reduced. But making the same assignment over and over, is there a way we can make this? Okay, so remember donkey variables? Can you see how this reminds you of donkey variables? Yeah, Abhirup got it. So what we can do is, instead of assigning the same thing to a variable and not even using what we're assigning. So the point of having a variable is using that variable. We are using that variable, the information in that variable, in a way. But when we are assigning something to A, we're not even using that. We're just immediately replacing it with another assignment. So instead of that, what if I just assign it once? Sorry, this is S. So now I have, this doesn't look very nice, but that's the logic actually. Just doing the same replacement 4 times. So does anyone have any other ideas to make this a little more readable? How do you think this could be better? To be honest, I don't have any other ideas. Actually, competitive coding problems are not very good for readability because the problems itself are not really doing much. They're like just question answers, input output based. So when you're working with projects with large amount of code, when you're working with real life applications, you'll see that those functions are actually doing something. The code is actually, it actually has a purpose. And it's not just to pass test cases. It has a function, it has a purpose, it's doing something. So when that happens, writing readable code is a lot easier. When you're just solving maths questions, you're not really understanding the point of readability. But I got these because these are some of the most unreadable pieces of code I have ever seen. So let's move on to the next code. So this is actually really difficult to read, so I have to go to the question. Let me share the question. Yeah, dislike of 3s. So we don't like integers that are divisible by 3 or end with 3. So those are disliked, and we just ignore them. So in this sequence, we have to output the kth element. So first element is 1, second is 2, third is 4, fourth is 5, and so forth. So this is the code that we have got from the submissions. It's a one-liner code. So there's only one line. So I can't even ask you the question, which line should we improve on, because it's just one line. We have to do the whole thing. Let's try to understand what it's doing. So for some reason, they've named this variable TT for test cases. Oh, I forgot to mention the underscore. This is a convention in Python, actually. Like normally you would think that an underscore is a terrible variable name. But in Python, we name variables with an underscore when we never use that variable. Like it's just there as a placeholder. That's what it is. It's a placeholder. We don't use it in our code ever, but it's there. So that's when we use an underscore in Python. So don't worry, this is not a bad coding practice, but this, I have no idea why. So test cases, and then print list of filtered with a lambda function, range 2000. Okay, range 2000, why? What's this 2000? Okay, another point. Do not have magic numbers in your code. A magic number is a number that has no explanation for being there. So over here, 2000, there is, no explanation as to why 2000 is there, because you need to read the constraints of the question to understand that. They've written 2000 because the constraints were 1000. So they just multiplied it with an arbitrary number. They thought doubling the constraints will be sufficient and will cover all the test cases. So this is test case based programming. You are just keeping an arbitrarily large number and hoping that, you know, it will satisfy all the conditions. So the constraints for K were 1000, so range 2000. But if you have to do something like this in your code, then I would suggest you keep some constant, global constant, and use that in your code. So range of limit tells you that there is a limit, like it won't go on forever. But that limit is defined over here at the beginning of your code. So again, what's the benefit of doing this? Maybe next day, if you realize your constraints have changed and now you have to keep the limit as 5,000, you don't have to go about searching your code for every instance or every occurrence of limit. All you have to do is make the change here and you're done. The rest of your code works, it won't break. So yeah, if you have to use magic numbers in your code, this is how you should do it. So similarly, let's try coding this for, let's do the test cases. Okay, now we need to find the kth element in the sequence. Wow. So let's keep a function which says like or dislike. So def is liked, and it returns a bool. So these are, so similarly in other languages like Java or C, you know what the return type is, you know what the variable data type is for the function arguments. But here in Python, it's not necessary, but it's a good idea to also define, to not define, but describe your parameters. So this tells me that the expected return type is bool or boolean. This tells me that the expected data type for the argument is integer. Now, I can also pass a string. It's not necessary that I have to pass an integer, but you know, it won't give me an error, but this is for conveying that to humans, not to the computer. So any person who's reading this code will know that, okay, this is what the function expects. So is liked, let me keep constant, because like I said, do not have magic numbers in your code. So what happens if a number is disliked? It happens when a number is divisible by 3, sorry, or if the number ends with 3. So disliked number. So what's the benefit of having something called disliked number? Again, if the next day the constraint changes and you say, you know, I don't like numbers which end with 7, then it will still work. My code still works. So again, all I have to do is return. This is a disliked number. So the name of my function is liked. So I could either do not of this, or I could change this to is disliked. I think is disliked is easier in terms of readability, so let's do that. So number is disliked. Let me keep a pointer equal to 0, and k is the number that we are taking as input. So k is taken as input. Now, while k is greater than 0, I just do a countdown of k. So I am counting k numbers. So every time I encounter a number that I like, I count down k. Okay, and pointer is 1 right now, and that's my first number. So while is disliked pointer, I keep incrementing it. And then when I'm done, I print pointer. Now, let me try this with some test cases. Okay. 10, 1. Wait, okay, my kernel froze. Sorry. This happens sometimes. K minus equal to 0, right? Yes, I'd fix that. So, yeah, good catch. I had to fix that. So let's see. First is 1, 2, 3 is 4. 4 is 5. 1000 is 1,666, and that matches with the test cases. Do you think this code is more readable? Well, yeah, definitely. Like, this was the original code. I definitely think this is much more readable than this code. So let's see what we're doing. So number of test cases. For each test case, we input the number k. We initialize the pointer to 0. And then we do a kind of counting down, k minus equal to 1. And every time we count down, we increment the pointer. So when the pointer is invalid, it's at a location that we don't want to count. We skip until we are at a location which we would like to count. And then when we're done, we've got the kth element, we just print the pointer there. Are there any questions over here? If not, then we can go to the last one. Now, this one is actually, it took me a while to, rewrite this code. I was writing this code like 1 hour before the session, and this took me a while. But can you tell me the main problem with this code? This code is actually not very non-readable. This can be read. This is easy to read. This is kind of clean, but there is a major problem with this code. Can you tell me what that is? Let me give you context. So this is a question. Let me just paste that here as well. No, map is not the problem. Map is a perfectly
Converting string to integer.
It's not non-readable. Like I said, this is readable, but there is a different kind of problem in this code. Here we have third line. Yes, what's the problem? So let me tell you the question just really quickly. There are 3 candidates in an election, and you have, okay, third line not very readable. That is true. You see the max portion is used many times, like thrice. But readability is not the main issue here. The main issue here is scalability. So let me tell you the question. There are 3 candidates in this election, okay? And you have the 3 votes that the 3 have received. So that's A, B, and C. So it could be like 10 votes, 15 votes, 75 votes. So let me give you an example. And for each candidate, you have to print the number of votes that candidate needs to win. So for this test case, candidate A has 10 votes. Candidate A would need 66 more votes to win the election, which means a total of 76 votes. Candidate B has 75 votes. Candidate B is already winning the election, so they don't need any more votes, so 0. Candidate C has 15 votes. Candidate C needs 61 votes more to get 76 votes, so they can win the election. All right, so that's the question. Suppose I have all three of them need 1 vote to win the election. Right? Does that make sense? If this is the case, then the 2 candidates which have 10 need 3 votes to get 13, and whoever has 12 doesn't need more votes to win. Or if it's like this, the candidates which have 9 votes need 1 vote to get 10 votes, which would make them the winner. And the candidate with 8 votes would need 2 votes. Now, what's the problem here is we have 3 candidates. Suppose, tomorrow we say we have, we don't have 3 candidates, we have 17 candidates. We have 20 candidates. Forget 20, we have 8 candidates. Even that would be a challenge, coding that in this solution. Do you agree? So what we have to do is have a solution that can be scaled. This is a solution that works very well for 3 candidates. And, 3 max functions is not very difficult to write, but a solution that would work for as many candidates as you want. So let's start. First of all, let's write some good variable names. So we'll keep that as votes, since it's votes that the candidates have got. All right, and now I want to keep track of the maximum vote. So max vote gives me the max of the votes. And now a problem is, the reason why I really struggled with this question is max vote is not enough. We need to know if the winning vote has a tie. So if it was 987, whoever has 9 votes doesn't need more votes to win. But if it's 989, then whoever has 9 votes needs 1 more vote to win. Otherwise, they're not winning. So we need to find a way to tell if, there is a winner or not. So I kept a condition, a bool condition, and that is votes.count max vote equal to 1. If there is only 1 person with the maximum number of votes, then we can say that the winner exists right now. Like right now, at this point of the election, there is a winner. And that changes our logic. That changes how we approach the problem. So let's have something called a winning vote. That is max vote plus 1 if not winner exists, else max vote. So winning vote, the votes you need to win, if the winner exists, then it's max vote. Like you need that many votes to win. If the winner does not exist, then you have to have one more vote than that. So in this example, the winner does not exist because there are two people with 9 votes. So the winning vote is 10. 9 plus 1, 10. So that was my logic. And in the end, I did a list comprehension, which was winning vote minus vote. That's the difference between what you need and what you have. But there was also a difference in the logic as to whether a winner exists or not. And that is, if the vote is not equal to the winning vote, which means you are not currently the winner, and the winner exists. So what happens when the winner exists? The winning vote, becomes max vote plus 1. And also you need another vote because you're not the winning vote. So vote not equal to winning vote and winner exists. So this was not very readable, right? Because it's difficult to explain this. Of course, I haven't defined what vote is for vote in votes. This is not really very readable, but what really happens is you get the difference, and that difference doesn't give you the exact answer. So you need an offset, and that happens only in a particular condition. The winner exists and you're not the winner. Then you need one more vote. So I did not find a way to write this in a better way. So, but what I want to stress on
The fact that we used better variable
names, votes, winning vote. These give you context. These tell you what it's all about. And the fact that this code is scalable. So in terms of code, like I would actually prefer this kind of a code over the previous one where we're using A, B, C and kind of hard coding it for 3 variables only. So that's actually the end of this. And do you have any questions? Because I am now going to start seeing if these can be submitted. Okay, the codes that we wrote. Okay, so the first one is we've hardly made any changes. Let's see the second one, if we can submit that. So if it accepts the submission, then that means that we've successfully done it. So let's see. Yeah, accepted. Nice. This was Roshan's code. Good job, Roshan. And let's see the next one. It's submitted. This one was just cleaning up. It should get submitted. We didn't really change the logic or anything. Mocha and red and blue. Accepted. This one was honestly, it's the code that I dislike the most. Coincidentally, it's called dislike number. Submit code. Threes. See if this works. Yeah, accepted. And now the last code. Okay, exactly the same code before, so okay, that works. That's been accepted. So I feel for competitive coding, original was fine. Yes, it was. Because like I said, competitive coding is just passing test cases. And if the question says that there's only 3 candidates, then there's only 3 candidates, and there's no way to refute that. But when you're actually coding in a project, it is very common for demands to change. It's very common for constraints to change. Constraints don't change in competitive coding. But in the real world, when you're actually coding in a company, companies like Google, they focus so much on scalability because one product is going to be used by so many people and the demands will keep increasing, usually keep increasing. So scalability in these are just toy problems, but they're not really some product that we're going to use. But I'm using those problems to show you important concepts, why we need scalability, why we use it in the industry, why we need to think about these things. You don't have to think about these things if you're just passing test cases, but I also want you to start thinking about these things from that sort of perspective, because you're not going to just do competitive programming, you're also going to work on projects in an organization with a team of people. So yes, all of those solutions are fine for competitive coding, and that's why they have passed all the test cases. They've been accepted. They've been submitted by people. I took real solutions like submissions. I went to Codeforces and I got submissions for this session. And they're all fine for competitive coding, yes. So are there any questions or something that you'd like to clarify? Based on the time it actually is the complexity. Yeah, so sometimes there needs to be a trade-off in the complexity. So very often you'll see that there is a code that would run faster. It's clever code, and it's not really reusable code, it's not refactored code, but it runs fast. It's actually better to have a code which takes a little more memory or a little more time, but is maintainable. It can be maintained by people in the long run. It can be scaled, it can be reused. So that's a trade-off that people make very often. Yeah. In the long run, you're working in a company which has money to afford RAM. So if you're using a little more memory, I mean, of course, if you're using a lot of memory, that's a problem. But trade-offs are small. Like a little small adjustment, if it can make the project easier to maintain, if it can avoid bugs in your code, if it can avoid misunderstandings or errors, that's very valuable. Those changes are important. So are there any questions? If not, then we'll end the session here. It's been, I think this is the longest session we've had ever. Thank you for your patience. And if there are any questions, feel free to reach out to me. I'm there on the Discord. I'm pretty active there. So reach out to me anytime. Thanks.